Okay, so 2.2, all you're really doing is you're like doing the transformations, you're looking at leading coefficients to take a look at what's happening. You're looking at the degree of the equation, so you know what's happening at the end behavior of the equation. Looking at your zeros to help you come up with a sketch, and then you're using the IVT to also help you come up with a sketch. So this first one is just telling you like what is a continuous function. And then this other one, this here is nothing new. This is where we talked about if it's an even degree, that means that the end behavior, nobody cares what's going on inside, the end behavior will act just like the even is a quadratic or a parabola. So the end behaviors are going to act like a parabola. The odd is just like a line, so the end behaviors are going to be like a line. So here, looking at this one, it says we want to sketch the graph of each of the functions. And so if I want to sketch a graph here, what I need to take a look at is just like what is, like here, what is the degree of it? It is a degree of 5, which means it's odd, which means it's going to have something to do with like a line. And the other thing is, if you think of a line goes from the left bottom corner and up, but the fact that it has a negative means it's going to go the other way. And I know that it has a 0 at 0, 0. And so really I'm just looking at something, and remember this is just a sketch. So when I'm looking here at my end behavior, I know that as x approaches infinity, my f at x goes to negative infinity. And as x approaches negative infinity, my f at x goes to infinity. Okay, let's do the next one. We'll do it in green. And what you should notice here is that the degree is even, which means it's going to act like a parabola. There's no negative in the front, so it's going to go up and up. And the other thing is if you think of a regular parabola, it goes at 0, but notice that you have a +1 inside the parentheses. So you always do the opposite of what it says, which means your 0 is going to be here at -1. And of course, you know, we can pick points or whatever and see, but really we're just kind of doing a very simple sketch. So we're looking at something like this. Again, as x approaches infinity, my f at x is going to go to infinity. And as x approaches negative infinity, my f at x is going to go to infinity because it's acting like a parabola. Okay, this is just a review. Again, we're just looking at the leading coefficient. And like I said before, if you look at this dashed area right here, we don't care what's going on there because the leading coefficient just tells us what happens at the end. So example 2, we're going to describe the left and the right end behaviors of each of the graphs. And honestly, I really don't need graphs here, so I'm not sure why I put graphs, because all I really care about is what's going on with my function. So the first one here, I'm going to do it in blue. This one here, it has an odd degree, and because it's odd, that means it's going to look like a stretched out S. And then the other thing is it's negative, so instead of going from the bottom to the top, it's going to go from the top to the bottom. So really all I'm worried about is this part here. There's something going on in between. So as x, oops, sorry, stop. As x approaches infinity, f at x goes to negative infinity, and as x approaches negative infinity, f at x goes to positive infinity. Okay, my next one we'll do in red. And so here I'm looking at this leading coefficient, and again it is an even function this time, therefore it's going to act like a parabola. So all I'm looking at is this part here, and then something's happening in between, but we don't care about that. So as x approaches infinity, f at x goes to infinity, and as x approaches negative infinity, f at x goes to infinity. They're both going up. And then our final one here we'll do in green. We're looking at an odd degree, and there's no negative in the front, so that means it's going to go something like a line, something like this. We don't care again what happens in the middle. So as x approaches infinity, f at x goes to infinity, and as x goes to negative infinity, f at x goes to negative infinity. Okay, so this is just talking about the zeros. In the statements, you says x equals a is a zero. It's a solution. It's a factor. It's an x-intercept. Like what it's saying is all of these are the exact same thing, just a different way to say them. So when we take a look at this one here, for example, number 3, what we need to think about is what kind of a function do we have? And so what we should do is we should factor this. So I'm going to go back to blue real quick. So I've got negative 2x to the 4th plus 2x squared. So what I can do is pull out a negative 2x squared, and I'm left with inside x squared minus 1. This is equal to 0 because remember I want to go ahead and factor this. So if I factor it, I now have negative 2x squared and x plus 1 x minus 1 equals 0. So I know that my real zeros are at x equals 0, x equals negative 1, and x equals 1. And the other thing I need to think about is my turning points. And so with the turning points, what you do is you look at your leading coefficients. So for turning, or sorry, your highest degree, turning points. You take your highest degree and you subtract 1. So there are 3 possible turning points in this case. Okay, so with repeated zeros, what you're looking at is you're looking at the multiplicity of your zeros. And this is going to make more sense when I do it, but you look at the degree or the multiplicity, same thing, of your zeros. And if it's odd, so if you think about an odd function looks like an S, which means it goes through the x-axis. If it's even, that's like a parabola, so it's really just touching it and jumping back off. And that's what these two things right here are saying. So it touches the x-axis and jumps back off, and if it's odd, it's actually going to go across the x-axis. So when we're looking at this function here, what we need to think about first is what do we got? So I want to go ahead and factor this, and so I can take out an x cubed and end up with a 3x minus 4 equals 0. So now I've got x cubed equals 0 and x equals 4/3. So what I want you to think about, like these are important numbers for us, and what you can do is you can kind of test it. So if you think about it, I've got 0 and I've got 4/3. So I can just see like what's happening before 0. So let's say a negative 1. So if I say x is negative 1, right? I can look at where x is 1, which is in between 0 and 4/3, and then look where x is equal to 2 and see what's going on. And really, all I want to know is like, what is the sign? Because the sign is going to kind of give me an idea of what's going on. So if I go negative 1 and I plug in negative 1, I've got 3 plus 4. So my sign is positive for a negative 1. And then if I go in between that and I plug in 1, so 3 minus 4, my sign is negative, which means it's going to go down underneath. And then for the next one, if I plug in 2, that means here I'm going to have a positive. Okay, so let's take a look at this. So I've got a 0 at 0, and I've got one at 4/3, which is about right here. Now, x cubed means it's going to actually go through 0. And if you look left of the 0, it is positive, which means I'm going to be up here somewhere. Now, in between, okay, now because it's odd, because this multiplicity is odd, it's going to go through the x-axis and then it's going to go down here to the negative. And then the next thing I need to think about is here, my multiplicity is 1. And so therefore, what's going to happen is it's going to go back through the x-axis. So the multiplicity tells you what it's going to do. So let's go through this next problem here, and we're just going to take a look again at some factors. So let's see. I want to pull out, I think I'll pull out a half. So I'm going to pull out a negative 1/2 x. And if I do that, that means I get 9 minus, and I'm pulling out a half, so this is going to be 12x, and then plus, and then here this is going to be 4x squared. Because if you think about it, this is equal to 0. If I plug this back through, then that'll tell you, you know, what it should look like. It should look like the original. So now I'm just going to put everything, I'm going to put everything in the correct order. Hold on. I didn't mean to do that. So negative 1/2 x, and then it should be 4x squared minus 12x plus 9 equals 0. So I can factor that, and that factors to 2x minus 3 squared equals 0. So now I've got a 0 here, this equals 0, and this one is going to be 3/2 with a multiplicity. This has a multiplicity of 1, this has a multiplicity of 2. So at 0, and I've got another one at 1/2. Again, I can take a look at my figures. So I need, let's see, x equals negative 1. I need x equals 1 and x equals 2. These are all one's on the left-hand side of this one. I've got one in the middle and one on the right-hand side here, and I just want to know what the sign is. So at negative 1/2, my sign is going to be positive when I plug it back in, and at x equals 1, my sign is going to be negative, and then after 1, my sign is going to be negative. I can take a look at this and just look at my end behaviors. So my end behavior here is that this is a negative 2x cubed, which means it's going to look like an S, a stretched S, and instead of being positive, it's going to go from the top, right, because the negative changed it. I've got a 0 at 0, and then with a multiplicity of 1, which means it's going to actually go through the x-axis. And then here at 3/2, I've got a multiplicity of 2, which means it's going to go up and bump it, up, bump, and come back down. And that kind of goes along with my end behavior as well. Okay, the intermediate value theorem. All the intermediate value theorem tells you is there is a 0 somewhere in between these two functions, or in between these 2 points. So when you're taking a look at it at the intermediate value, you're just seeing, is one of your y values negative and is one of them positive? And this is used a lot in AP Calc. So using the intermediate value theorem to approximate. So I'm first going to just kind of look at some points. So I'm just going to pick some easy points to take a look at, and that's going to tell me if I have some zeros or not. So we're looking at -2, -1, 0, and 1. So if I plug in -2, I end up with a -11. If I plug in -1, I've got a -1. If I plug in 0, I've got a 1. So what that tells me right now is in between here, there is an x-intercept because I go from a negative y value to a positive y value. And then if I go ahead and plug in 1, I get 1. So if you think about it, if I kind of graph this and go, okay, so at -2, it's -11. It's down here somewhere. And then at -1, it's -1. At 0, it's 1. And at 1, it's 1. Again, I can look at the end values. Because it's odd, that means it's going to go from down here and it's going to cruise up, and I'm going to go through the x-axis, and then I need to kind of go up again because that's my end behavior. So intermediate value just tells you that you have a 0 somewhere along there.